It is Sunday, and welcome to all my viewers, and welcome to, I even managed to point the right direction. Welcome to our guest today, Mark Smith, from the Ham Radio Workbench podcast, and also Halibut Electronics. Would you like to introduce yourself, Mark?
Yeah, hi. My name is Mark Smith, N6MTS. I'm also known as Smitty or Smitty Halibut in several different contexts. I have been in IT for mumble decades, I think about 25 years, 30 years, depending on how you count it. But I left that job about a year and a half ago and to pursue a passion project of mine, which is electronics and audiophile electrical engineering. So I'm designing hardware for the amateur radio market and for the audiophile market now.
Excellent, excellent. And I actually have your website up here, so I can just show that to the viewers if I just figure out how to share my screen, which I always struggle with.
How do I StreamYard?
Yeah. Or how do I keep a little bit fewer tabs open at the same time? Let's see here, and let's see if we can get to your front page here.
That's it.
Yeah, that's it. So I see you got a couple of interesting projects here, as far as I can see. But we're not going to talk about any of the projects on your front page right now. At least we'll see what time permits after a while. But what really got me interested and what really made me ask you to be on is your work on the Open Headset Interconnect Standard, which I've heard about on your podcast, and it's basically not just your podcast, but you're here now, the Ham Radio Workbench. And I've been trying to visualize that, and I figured probably a lot of my viewers and a lot of your listeners have the same problem as well. So I'll just leave the mic to you, and you can talk a little bit about your project.
Yeah, sounds great. Thank you. I just pasted a link in the YouTube chat, and then I also pasted it in our private chat if you want to put up I can, a bubble with the link.
Yeah. So I don't think you're able to post in the YouTube chat though, so I'll post it for you in the comments here.
Oh, I've got YouTube open in another tab, so I just posted it as a normal viewer.
Yeah, but I don't think YouTube stops the links though, so only you can see them, not everyone else.
Interesting.
Yeah.
Okay. Yeah, I see it on mine, but okay. Anyway, Open Headset Interconnect Standard. The webpage is OHIS.org. I was surprised as heck that there was a 4-letter domain in the .org top level that was still available, so I went ahead and registered it. But we now have a place to put everything. OHIS.org. It stands for Open Headset Interconnect Standard. The elevator pitch I use is that in amateur radio, we have standards for things like electrical power, right? A lot of our radios run off of 13.8 volts, plus or minus 15%, right? 12 volt electrical power. May have different physical connections, but because it's all the same electrical standard, it's relatively easy to switch back and forth between the different physical standards. Similarly, on the RF side, we have the standard of 50 ohm coax, right? An unbalanced 50 ohm impedance transmission line. We have different connectors, right? PL259 or BNC or SMA or whatever. But again, because it's the same physical standard, it's relatively easy to switch back and forth between those. I'm sorry, because it's the same electrical standard, it's relatively easy to switch back and forth between the different physical standards. We do not have such a standard between the radio and the user. Right. So the things that go between the radio and the user are the microphone, the headphones, or the speaker, the push to talk. Those are the 3 main signals that OHIS concerns itself with. And like on the microphone, there are 3 different common electrical standards. And as I play with this more, I'm finding more and more weird and wacky things that manufacturers do with microphones. But the common ones are dynamic microphones, which are often used on HF radios, non-ICOM HF radios anyway. That's what Bob Heil likes to sell. He makes very good dynamic microphone elements. But dynamic microphones are incompatible with electret microphones. ICOM uses Electret on their HF radios, and most mobile rigs, VHF, UHF use Electret microphones. Yeah, exactly. If you have the little handheld speaker mics, those are typically Electret as well. And electrically, they are different. You can't just plug one into a system that is expecting the other. There's a third type of microphone that's not as common as the other two in the ham world, but it's called carbon or carbon equivalent. It's used very commonly on aviation headsets. So if you have or use an aviation headset with your radios, you need to adapt from the carbon microphone to whatever it is that your radio expects. So microphones, we've got lots of different standards. Similarly, on the headphones, we've got lots of different standards. Is it headphones, like just a standard stereo headphones? The headphone is a pretty standard thing, but a lot of radios don't have headphone outputs. They just have speaker outputs. Speakers, you can't just plug a speaker output into your headphones without blowing out your headphones, because that's a lot more power. Similarly, are those speakers ground referenced, or are they push-pull? Right? If you try and send a push-pull speaker output to a headset that shares a ground between your microphone and your headphones, you're going to blow some things up, right? Or maybe it's line level. It's roughly the same voltage as a headphone level, but it can't push enough current to be able to actually drive your low impedance headphones, right? All of these, I've seen all of these on different radios, and the user has to do different things based on what the radio provides.
Exactly, and it's not always well documented either what's on the different radios. So it's kind of a minefield for the end user.
I am finding, especially on mobile rigs, that they expect you to use their microphone on their radio, and that's it. And so they don't bother documenting what's there. Like the D700, which is the radio that I have used and loved for many decades. The D700 is an Electret mic, but they don't provide DC bias over the microphone line. They provide it on a different pin, and then it gets combined in the microphone. It's weird. I have to do like level matching. Anyway, it's weird. It's complex. So what Open Headset Interconnect Standard does is it defines a standard in the middle. Oh, sorry, I skipped a step. All of these different standards make it very difficult for me to take any arbitrary headset, my headset, the headset that I like to use, to a radio and connect it without having the exact adapter that goes from that headset to that radio. And at your own station, that's not that big of a deal, right? Because I can buy that one adapter or make that one adapter for this one headset to my one headset to my one radio. That's not that big of a deal. But if you go into a multi-user environment, either like a club station or an EOC or a contest station, like if your club puts together a field day event, right? And it may be that, you've already got the adapters for your radio, and you may already have the adapter that goes to the club radio at the shack, but your buddy who's also a member of the club brings their radio to field day, and you don't have an adapter for that, right? So anytime you have a multi-user, you don't know ahead of time what headsets are going to work, or what headsets and what radios you're going to use. It would be nice if there was a standard that I can say, with these electrical standards and this physical connection, everything will work on it. So that's what OHIS does.
Exactly. And I got a question here from LB4FH here. He asked if you named the project after the free domain.
No, I did not. In fact, I didn't register I didn't even bother looking for the domain until months after I started working on this project. Like, I literally just found that the domain was available a week or two ago, and I've been working on this since before September of last year, of 2022, because September of 2022 is when I gave the first presentation on this at the QSO Today Virtual Ham Expo.
Yeah.
So this has been months that OHIS.org has been sitting there waiting to be claimed, and I didn't even know about it. Good question, though. That is not an uncommon thing.
It is not, absolutely not. So, but it seems like you at least have some kind of on paper, some concept of how to solve this issues at the moment.
Yes. So let me. Okay, it's a very long elevator ride. Let me finish the pitch briefly, and then we'll go into talk about what the actual standard is.
Yeah, exactly.
So, so now that I've got I'm going to define a standard in the middle, and then we're going to make adapters that go with the different devices. So I'm going to make one adapter that goes with this particular radio, and it adapts whatever this radio has to the standard. And that adapter stays with that radio and never leaves that radio. Similarly, on my headset, I'm going to make an adapter that goes from the standard to my headset, and it stays with my headset no matter what happens. And so now I, as a user, have bought a headset. All I have to do is buy one adapter, or ideally, someday headsets and radios will come with OHIS ports on them like natively. We got to get some adoption before that happens. So for the time being, I am assuming everything's going to be using an adapter. But hopefully those adapters will disappear and be absorbed into the devices in the future. But for now, I buy an adapter or make an adapter that goes from my headset to the standard. And then we buy an adapter that goes make an adapter that goes from the standard to the radio. And now we have one adapter for every device. And I now no longer have to worry about what my headset is going to plug into, because I know I've got a standard a standard interface on my headset, and all the radios I'm going to connect into have a standard interface. And I no longer have to worry about the mapping between all the headsets and all the radios. I can take my headset to any radio. That's the goal. Okay.
Yeah. I got a couple of comments and questions here while you were talking. LB4FH here again says that even the same manufacturer changes their standards, and that's not an uncommon issue, not only in the radio world but everywhere, and that even makes it harder. And I see that Stian here, LB3FJ, asks if there will be a computer sound card for this.
So let me respond to those separately. Not only do given manufacturers change them, but even if you have the same physical connector, like the 8-pin round connector, all three of the major HF manufacturers, like ICOM, Yaesu, and Kenwood, they all use that same connector, but none of them are compatible. Like, they're all different pinouts, right? So even if you've got like the right connector to the right connector, like making sure the pinout is the same, and then different manufacturers have different signals. Like, one's an electret, one's a dynamic, right? So yeah, the adapter game is just an absolute mess. And then the question is, can there be a sound card version of this? Yes, there's nothing stopping one from designing a USB on one side that looks like a sound card to a computer and an OHIS interface on the other. You would have to make two of these devices, one that is a OHIS user side and one that is an OHIS radio side, depending on what it is you're trying to accomplish. Whether you want it to look like a headset to a radio, or whether you want it to look like a radio to a headset, because the standard is not symmetric. There is a radio side and a user side. Just like in serial, RS-232 serial, there was, data terminal equipment and data communications, DCE and DTE. There were different sides of the serial line. Same thing is true here, because microphones and headphones are very different. You can't just connect one to the other. So it is sided. It is not symmetric.
Exactly. So, but how far are you away from having a physical product to show?
Hopefully only a couple of months. So talking about products brings up another issue. OHIS is a standard. It is not a product. It is a document that defines what the electrical signals are and what the physical connectors are. Very simple, hand-wavy summary of what all the signals are. Headphones are ground, left, and right, standard headphone connection. If you need to drive a speaker, you can amplify headphones into speaker easily. If your source is if you need a line level, you can plug a headphone source into a line level input, no problem. So the audio out from the radio, the standard is standard headphone level. The microphone is mic plus and mic ground. It is electret level. So the radio side provides 5 volts to the user side, and the user side sends about a hand-wavy 45-ish dB SPL microphone level back to the radio. If you don't know what any of this means, don't worry about it. I'm just hand waving for the people who actually are curious what the electrical standard is. Headphone ground, microphone ground, and power ground are all kept separate. So you can do balanced signals or pseudo-balanced microphone levels. Let's see here. So those are 5 of the pins. There's a PTT, which is just a GPIO pulled to ground, the power ground. So simple contact closure for push to talk. And then the radio side provides up to 200 milliamps of 5-volt power and a power ground that can be used for devices in the middle of your OHIS. So like if you wanted to put an EQ between your headset and the radio, in theory, somebody could design just a simple microphone equalizer module, that takes the microphone audio in, does the EQ stuff, and then sends it onto the radio. Power is included in the standard to be able to allow for devices like that. So that's it. 3 pins for headphone, left, right, and ground. 2 pins for microphone, mic positive and ground, and those are separate grounds. Then plus 5 volts and power ground, and then a PTT. And that gives you 8 pins, and those 8 pins are carried over an RJ45. The actual pin out of that is in the document. There are standards included for alternate, more rugged connections, physical connectors if you need them. But it's strongly encouraged that everyone stick with RJ45 just for interoperability.
Yeah, and just sort of my personal curiosity here, have you considered using EtherCon for your RJ45 connectors?
That is in the standard. I don't think I've pushed that change up to GitHub yet, but yes. So I recently learned about EtherCon while trying to find an 8-pin XLR. It was what I was looking for.
Yep.
The XLR standard only goes up to 7 pins. Curses. And I was hoping to find an 8-pin XLR connection. That's what I was going to use as a rugged connector option. And while searching for that, I found EtherCon, and I'm like, that is perfect, because now you can stick an EtherCon socket on the front of your radio side interface and either plug a normal RJ45 into it or plug an EtherCon connector into it. EtherCon is basically just RJ45 inside an XLR shell.
Exactly, and it's really rugged. I use it in my daily job as a sound engineer, and it works perfectly because once it's inside, you can't break it or anything. It's really rugged.
Yeah. So that's in the document as the preferred rugged connector for OHIS. I think I also define a optional standard for DB9, or excuse me. Oh God, I can't believe I just did that. DE9. This is one of those hills I'll die on. It is a DE9, not a DB9. And I think somebody else put in a strong recommendation for it was 6-pin mini XLR, but 6 pins doesn't give you enough pins to do everything with OHIS, even if you use the shield. So I think the 6-pin left off power as an option, at which point I'm going to basically use the pinout that Radio Sport headsets use. Radio Sport headsets are almost electrically identical to OHIS, except that they do not provide power in their connector.
So I got a couple of questions here now. Steve KO4AFL asks if all electric mix, and I think he means electret mics here, are created equal.
Yeah. So pedantry, it is electret, ELECTRET, not electric, IC. It's I'm not going to go into the distinctions between the two, but they are electret microphones. Are they all created equal? The capsules themselves mostly are. Some will have different sensitivities than others. And that's why I get very hand wavy on the mic sensitivity. They tend to be somewhere between 40 and 50 dB SPL. dB SPL refers to how many decibel milliwatts of power into a given load impedance is generated by the microphone based on a certain amount of audio energy coming into it. SPL stands for sound pressure level. So how many dBm, decibel milliwatts of power, into a usually 1.5K load for electrodes, 600 ohm for dynamics. It's the math gets weird, but basically it's how loud is it, right? For any given volume going into the mic capsule, how much energy is coming out the other side is what the dBSPL levels are. And so they tend to be between 40 and 50 dB.
Yeah.
But otherwise, they all require DC bias and with some DC or current limiting resistor on the outside of it. Now, that's the capsule. Like I was saying, I can't remember whether I said it here or not, but the a lot of hand mics, like my Kenwood D700, the hand mic itself has an electric capsule inside of it, but the DC, yes, that one. Yes, exactly that one. It has an electric capsule inside of it, but the DC bias voltage is not on the mic plus pin. It's on a separate wire, and it gets combined inside the headset, which is inside the handset, which is annoying because now the RJ45 plug that we're connecting into is totally unique. It's really annoying. Anyway, so they're mostly created equal, but not entirely.
Not entirely, exactly. And LB4FH has got another question here. If there's a way to use a PC headset with a separate PTT.
Yes. So OHIS does not talk anything about how you are building those adapters. OHIS itself only talks about the standard in the middle. And then anyone can design any adapter to use that standard. So I am here as representatives of two different parts of this story. I am the primary representative of the OHIS standard, and that's what's at ohis.org. I am also here as a representative of Halibut Electronics. Excuse me. Halibut Electronics is a company, is a for-profit company. It is my day job that makes electronics, and one of the product lines that I will be doing is making OHIS adapters. My OHIS adapters are proprietary. I share a lot of information on my mailing list if you want to go learn more about what's going on. I'm not very good at keeping intellectual property private. So subscribe to the mailing list, Halibut Electronics on groups.io if you want to learn more about what I'm building. But my devices are not open source. I am designing them myself. So being bad at sharing things or being bad at not sharing things, one of my early test headsets is a PC gaming headset. It is a 4-pin, 3.5 millimeter. This connector is technically called CTIA. It's a communications I don't remember exactly what it is. Common telecommunications, blah, 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 blah. It's the standard headset interface for most phones. The pin out is at the tip down to the shield, left audio, right audio, ground, and then microphone. And the headphones and the microphone share a ground. And this was one of my first earliest headsets because they're cheap. These are like $25. And they're electric. The microphone elements are electric. So when you plug this into a telephone or to a PC, like a lot of laptops have a single 3.5 millimeter socket for their headset now. It's this. That's an electric microphone. So adapting this to OHIS is trivial. It's just wires, right? It is literally connecting that to an RJ45. So yes, this becomes very easy to make a CTIA to OHIS headset adapter. Oh, come on. I thought I grabbed this beforehand. Which happens to be, well, I'm going to lie to you. Oh, nope, there it is. Nope, that's not it either. Okay, I'm going to lie to you. It looks an awful lot like this.
Yeah.
The Halibut Electronics device that I'm selling is going to come in this small Hammond. This is what it looks like when it's all put together, although this one is configured differently. This one's configured for a microphone like this, a balanced dynamic mic. Yep. But it's got an OHIS port on one side, and then it's got like a headphones, microphone, and PTT socket on the other side. And then it has this field of jumpers in the middle that allows you to connect any signal to any pin. And so you'll notice that this one only has one of those two sockets populated, and those jumpers down there happen to be putting like left audio, right audio, headphone ground, and then mic plus and mic ground onto the appropriate pins of that socket. So this adapter here, you plug a CTIA headset in there, and then there's your OHIS cable. There's your OHIS port. So short answer to your question is yes.
Yeah. So, but this is starting to look really promising. I see Steve here comments that he needs an adapter for his aviation headset, and that's kind of the goal behind this, isn't it, Mark? That no matter what kind of headset you have, and no matter what kind of radio you have some kind of middleware to fit everything together.
Correct. So aviation is my design. Here's another iteration of that same interface, right? It's got the OHIS on one side and then the 3 sockets on the other. And then it still has that jumper field, and the physical jumpers here, these can be rotated 90 degrees to either put in line or remove from line a a microphone preamp that will take a dynamic microphone and boost it up to electret levels. And so you can use a dynamic microphone on that adapter as well. Aviation headsets are a little bit harder because carbon, well, it's not harder. You have to do different things that my design doesn't handle. It would not be difficult to make a design similar to this for aviation headsets. I am not targeting aviation with my first release of hardware. I probably will at some point in the future, but my first release of hardware is going to handle electrets and dynamics, which are the 2 most common for non-aviation headsets. And then I will expand from there.
Yeah, but there's nothing in the way of Steve designing his own aviation headset adapter then, since it's American standard.
Correct. And in fact, I think I've already been emailing with Steve. I think I recognized his call sign, KO4 AFL.
Yeah.
Steve, are you the one that I've already been emailing with? I think so. Yes, I encourage people to design their own interfaces. This is an open standard. I want people to adopt this, and adoption is going to involve getting as many people. Yeah, Steve confirms that we've already been chatting. Adoption is going to involve getting people to use this thing. So I will help anyone design their own stuff that they want to build themselves, or even if you want to design a product and sell it, I will help you with that as well. My financial motivation behind the standard is personal. This standard has needed to exist for a long time. But also I want to design devices that go between the radio and the user. And if I have to, such as this one, my contesting console, which we may talk about a little bit later, if I have to design it so that it can work with any headset on the one side and any radio on the other side, that adds a lot of complexity to my device that I design that goes in the middle. If I have a standard in the middle, that makes my device so much easier and cheaper and to build and design. And so that's the main reason why Halibut Electronics is sponsoring this, is I want this standard to exist for other things that I'm working on.
Yeah, and having that middleware makes everything a lot easier, doesn't it? As we've talked about already.
Yeah.
So do you have a timeline for when users can buy physical products here?
Yeah, so that was a question you asked me about 20 minutes ago, wasn't it?
Yeah,
and then I never got around to answering.
Yeah.
My goal is to have a small batch available to early adopters, the consoles, but yes, I need 2 of those as well. Working on it, Steve. I can't remember whether I actually sent you pictures and email about it, but this is what the contesting console looks like. You can tell I haven't finished building it yet, but this is the board as it came from the fab house. Sorry, I keep getting distracted. My goal is to have early versions available for early adopters to help me start testing around end of March, April timeframe. if everything goes to plan, knock on wood, I'm hoping to have some hardware to sell at Hamvention in Dayton or Xenia, Ohio this year. I will at least have hardware to demo in Hamvention at Hamvention. But if things go remarkably well, then I will have hardware to sell. If not at Hamvention, then shortly after that. So summer-ish, late spring, early summer.
And I guess anything electronically these days are kind of affected by the chip shortage. Although I'd imagine you kind of designed the products around that issue, though.
So there's nothing I'm doing that requires anything other than Jelly Bean parts. So, as in it's op amps, right?
Yeah.
Like it's, you can buy op amps from so many different manufacturers and they haven't gone missing, right? It's the like very specialized STM32s that are hard to get a hold of. There's nothing digital in this at all. There's op amp there. That's a headphone amplifier. So the LM4808, the pinout wise looks like a dual op amp, but it can supply a whole lot of current, a lot more current than most op amps can. And that's what I'm using for the headphone amplifier. But other than that, they're, RF chokes, resistors, capacitors, connectors, voltage regulators, transistors, opto isolators, audio transformers. Like none of this is chip shortage kind of problematic parts. So this one has not given me problems from a chip shortage standpoint. Knock on wood.
That's good. So it's actually a relatively realistic timeline then, Mark.
Excuse me. The only thing that's going to make this go longer is if I don't find all the problems with my current design. I made a lot of stupid mistakes on this particular revision. This is only my B revision. It's the second one I've made. And I was all confident that it was going to be great. And I went in and made some really silly mistakes. And then on top of that, I have found other things that stock radios are doing that I didn't expect them to do that I now have to consider. For example, one of my stock radios, and I'm not going to mention any names, has a resistance in parallel with the microphone element, which means that it's always pulling DC current. And that's not that big of a deal, except for the fact that that DC current causes a DC voltage to drop across the resistor inside the radio. So it's like 5 volts power, then there is a current limiting resistor in the radio, and then that goes across the wire to the microphone element. And usually there's just the microphone element on the other side. But they have a resistor in parallel with that microphone element, which means there's always a DC current flowing through here, which means there's always a voltage drop across this resistor that I don't have access to. But then there is a capacitor on the other side of this that has that blocks the DC going into the amplifier inside the radio. But that DC drop across this resistor here means that there's a DC drop across this capacitor. And if I am not replicating that voltage drop, now this capacitor has to resettle. Like it's got a, call it a 3-volt drop across it because it's dropping DC. That's what it's supposed to do. And then as soon as, if I'm not pulling that same amount of DC current through this current limiting resistor, that voltage across that capacitor changes. And it will only dissipate that voltage through the resistance on the far side, which is a very high resistance because it's an amplifier. The end up of this is that like the first second and a half of when I key up, there's no audio. And then the audio, I'm sorry, for the first 1 second, there's no audio at all. Then the next half second, it's heavily distorted. And then it's fine because there was the audio signal is centered. And then all of a sudden you got this giant transient DC shift and it goes way outside of the rails of the amplifier. As that DC dissipates, it comes back in. And right here, it's at the rail and you get half of your audio signal. And then it finally settles into its middle point and it sounds fine. And then you unkey and the same thing happens on the other side. And so like you've got this audio signal moving back and forth between your center and it every time you shift between the stock microphone and the OHIS microphone, because I'm not pulling that DC current, it causes that 1.5 second transition period of crappy audio.
Yeah.
And so I've discovered that I have to put a resistor in parallel with my microphone element to draw a DC bias current to match the DC bias current that's being drawn by the stock mic. Because if I'm drawing the same amount of DC current, then it doesn't shift, right? It stays where it is when I change from one radio to the other. Like, this is something I never even considered when I was designing these things. So
now we're back to the part of documentation not always being present, and if it's present, not always being good.
Yeah. So
anyway,
anyway,
I see that Andy Cowley asked here if we're able to buy this outside the U.S., and I'm actually interested in knowing that as well.
I can ship worldwide. There is no radio in this, so I don't think there are any regulatory issues with me shipping this worldwide. The standard, obviously, is just a document, so you can download the standard and design or build your own if you wanted to. But
I think he asked about the Halibut Electronics.
The Halibut Electronics products.
Yeah.
Yes, I do sell internationally. I think I only sell in US dollars, so you will have to do the currency conversion on your side of the transaction, not on my side. But my shipping company, my postage company, is called Pirate Ship, and they have a international service that's takes a long time, but it's reasonably priced.
Exactly. So that's good. And that's kind of that is sometimes an issue for us being outside the United States, so not being able to get those products we hear about and see.
Yeah.
So I'm happy that you're able to ship internationally.
Yeah, me too.
Yeah. So I don't know if any of the viewers has any questions to you about this.
What have I missed?
You've missed a lot, William, but you can always watch it in replay. Lina asked if you take PayPal. If so, they'll do the magic money translation for you. And not only PayPal will do that, most banks will do that for you as well. So and usually with better currency rates.
Yeah, I don't use PayPal. I had one bad experience with them, and maybe I'm holding a grudge, but I had one bad experience with them as a vendor, as a business when I first got set up with them. They pissed me off. So no, I do everything through credit card. I use Stripe for my credit card processing.
Yeah.
If you absolutely have to use PayPal for whatever local reason, send me an email and we'll figure something out. But my preference is to avoid PayPal if I can.
And I see Andy just comments, great. So I guess you got a potential customer there. Jim asked what radios you're focusing on initially.
So I am okay. Actually, I haven't even shown this yet. So this is the radio side adapter that I'm developing. It is. Let's see here on the radio side. So actually, this one doesn't have all the connectors on it. Let me just go ahead and disconnect the one that does.
Yeah,
so you can see it. Hey, get out of there! Come on, there we go. Gravity is a jerk. So this is a radio side adapter. I'm calling this the Halibut Electronics Radio Adapter Pro. On the back side, you have a RJ4 Anderson power pole for power, and then one of three different options for microphone connections. You either have 8-pin round, it's called the GX16 is the model number, or an RJ45 or a 3.5 millimeter socket, TRRS socket. So any one of these three for microphones. For speaker or headphones, we've got a 3.5 millimeter over there. And then if your radio has a separate PTT, we've got a dedicated RCA PTT socket over here. In the middle is this giant field of jumpers. Now, this is a removable board. There we go. This is what that board looks like. It's just a simple board with connectors on the bottom and then this giant field of jumpers. And horizontally are pins on those connectors. Vertically are signals. So it's just a giant connection matrix. You can connect literally any signal to any pin. So that board is where you define the pin out of what connector are you using for your radio. And there are separate pins for each of these connectors, not the PTT. The PTT is hardwired, but all of the other ones, so you get to specify what signal is on what pin using that daughter board. Then on the other side are pass-through connectors. So this side you connect to the radio. This one you connect all of your radio's stock devices. So if your radio comes with a stock 8-pin round microphone, you connect it right here, and you can still use it as normal. Same with the RJ45 or the 3.5 millimeter. So all of these are called pass-through connectors, where you can use you don't lose the functionality of the normal devices that your radio is designed to come with, but it also has an OHIS port on the side here. And so all of the electronics in here, they take the signals from the radio, whatever they are, they adapt them to the OHIS standard and make them available on the OHIS port. And then, so the audio out from the radio, either the speaker or the headphones, it gets split and sent to both. Right. So you can listen on the normal speaker or headphone socket on the front or on the OHIS, and they both work at the same time. The microphone audio, if you press the PTT on the pass-through, then your microphone audio just gets passed through from the pass-through microphone device, right? So the radio's stock microphone will work just like normal. But if you push the PTT on the OHIS device, then it will flip a relay and pass the microphone audio from OHIS into the radio. And so it just switches which microphone gets used based on whether the OHIS PTT is what's being pressed. And then it generates the 5 volts.
Just a little bit of an interruption here. So that means that you can have both your radio stock microphone and another microphone connected at the same time.
Correct. That is not a part of the standard. The standard is literally just what signals are on which pins for this port, right? All the other functionality I've described here is a Halibut Electronics proprietary device.
But that adds to the functionality of the device, though. It makes it a lot more user-friendly for the end user.
Yep.
So I'm liking that, and I see that Andy comments that he'll take one right now.
He'll take one now. Working on it.
And I see that LB4FH here, as if this will be mostly for stationary operations, and I guess he's talking about your products here. And he's also got a really great portable operations YouTube channel, so I can see where his questions are coming from.
So in a portable operations, if you're trying to optimize for weight, these products are not optimized for weight or size. These products are optimized for, sitting on your radio shelf next to your radio, for permanent stability and connection quality and stuff like that. If you are trying to go hiking, you have one radio with you and one headset with you, you're probably going to be better off not using OHIS for that, because you don't have the problem of lots of different headsets and lots of different radios, right?
Exactly.
And in that case, you're probably better off just making a single purpose adapter to go from your one headset to your one radio.
And I see that he comments everything is in his portable kit is optimized for weight except himself. And for those of you guys who are not subscribed to his channel, check it out. And he even made a video today about how to optimize your radio gear for weight when going out portable. So
I don't think OHIS is the solution to a weight optimized portable situation. If you're doing portable like a club field day or something like that, where you've got lots of different users, then yes, OHIS will definitely come in handy there. But this is meant to be one product that will work on lots of different radios, right? Like I have the jumper field and all of the trim pots and everything for level matching is a separate board that can be, I can make lots of these boards for different radios and then have just this part with all the expensive bits, make only one of these and then just match the right radio board for this, right? Shoot, there was somewhere I was going with that. I have completely lost where I was headed with that. Man, ADHD is a curse. Okay.
So
I'm going to watch this video later and go, oh my gosh, I was going to talk about blah, blah, blah. Anyway.
Yeah, and then you can just leave it in the comments down below, though, so people can see where you were going. And Steve comments that for club trailer or similar, this is gold. And I guess if you're thinking about portable with this, it's more of a parks on the air situation than it is a summits on the air situation, I would guess. And at least for my perspective.
But yeah, it's going to be anywhere you have multiple users is really what it boils down to.
Yeah. Or multiple. Is there any way to connect multiple radios to one of your boxes there?
So that is, remember when I said earlier that I want to be able to sell devices that go between the user and the radio?
Yep.
That's one of them. So I don't remember whether I talked about this before or during the show, but this is what I'm calling my contesting console. It is, you have two different OHIS ports, one on either side, for a logger and an operator. And then each user has, is that my phone or your phone?
I don't think it's my phone. My phone is the camera that is here right now. So.
Okay. Okay. My apologies. I can't tell if that audio is coming through the stream or not.
No, it's not coming through the stream, so none of us can hear it.
Oh, I'm just hearing things. I'll shut up and let it and deal with it. So this is a logger and an operator, and then each user has a 4-channel mixer where they can listen to their own audio, the other person's audio. Seriously, that is getting really distracting. The radio audio, and then an ambient microphone. And the idea being that each user can use it as an intercom to talk to each other. What's going on? Okay, the people in the chat are saying that they can hear it too.
Yeah, I cannot, but that might be because I worked at a concert until 3 a.m. last night. So,
so your ears are a little ringing.
My ears are kind of Sunday nighty. They'll normalize sometime through Monday.
Okay. Try muting yourself real quick. Sorry, stream. This is exciting audio.
Let me just.
Yep, and it's gone.
Okay, that is actually my microphone, and that's or my phone. Just hang on. You'll lose my picture for a little while, and I'll be right back.
All right, sounds good. So I'll go ahead and continue talking about the contesting console. So every user has their own 4-channel mixer where they can listen to their own audio if they want a little bit of talk back. They can listen to the other operator, so they have an intercom. They can listen to the radio, and then they can listen to an ambient mic. The idea being that the way I do field day, my club does field day, is we've got an operator and a logger, right? One person sitting in front of the laptop, the other person's operating the radio, and they work together. And a lot of times they need to be able to. Do you have a balloon over your house? They just shot that down. It's okay. But they need to be able to talk to each other and say, what was that call sign again? That kind of thing. Yeah. And so that's 2 users and 1 radio, but that's a device that I'm able to make much more simply because OHIS exists. And then there's 1 OHIS port that goes out to the radio itself. And I'm able to make that very simply because OHIS exists. I know what the microphone levels are going to be. I know what the radio is expecting, and I don't have to make the device generic to work with all headsets or work with any radio, because I have those defined standards, and that makes this a lot easier to design. I also intend to do instead of multiple users on 1 radio, have it go the other direction, have multiple radios for 1 user, and have like 4 different inputs, 4 different OHIS inputs, each with their own volume. All of the audio outs get mixed together and sent to the headset. The microphone audio gets amplified and split out to all 4. And then there is either a switch to choose which radio gets your PTT, or 4 different PTTs, or some other system. I haven't figured out exactly what that's going to be yet, but basically 1 user and multiple radios. That's another thing that absolutely can be built like this, and I plan on designing.
And I really like that concept because I can't be the only ham that has more radios that I'm ever gonna use to make to be able to connect to. And I'll just you didn't go far away, so
Nope.
I was just wondering if still could hear me or not.
Oh yeah, no, I take my headphones with me.
Yep. And exactly, and for me being able to operate several radios at the same time, that'd be excellent. Yeah.
So this is a 1U rack mount panel that you can screw these boxes directly to, just using the screws on the front panel of the box itself, and so you can fit multiples of these in 1U of a rack. If you're like if you're a nerd like me and have a rack in your shack,
and that's a 19-inch rack, right?
Correct. Yeah. And then you'll notice that this panel doesn't actually have, it's just got open holes in it. And that's because I plan on designing different devices that use that same physical form factor, but with different sockets and whatnot on the front. And so this one panel will be able to fit multiple different types of adapters in there.
And I see that several of my viewers comments that it's a neat design, and it really shows that it's well thought out, though. And it looks and seems like it'll be working excellent. So I'm looking forward to seeing products with the Open Headset Interconnect Standard.
Me too. Like I've been living off of savings for the last year and a half. I tried to get my first product, SOAR, out off the ground, and I got really darn close. But there was one problem with a third-party module that was a showstopper problem that I was never able to resolve. And at some point, I just had to put it on hold. It's not canceled, but it's on hold, and say I got to get something out that I can make money on, because it had been a year at that point that I've been living off of savings, and I'm like, I can't, like, I don't have a path to success on SOAR right now, so I put it on hold to work on this other stuff.
Yeah. So and that was a nice segue, because I was gonna kind of take it a little bit onto SOAR, though, because that's also a product that looks really promising. But does that mean that SOAR is kind of a little bit delayed at the moment?
Very delayed. It is almost certainly not going to look exactly like it does now. So what is SOAR? Satellite Optimized Amateur Radio. It's an appliance for operating FM satellites. I made a dual band full duplex radio, so you can transmit on one band and receive on the other band at the same time, which is very useful when operating FM satellites. It has a GPS in it, so it knows where it is and when it is. And then it has SD card storage inside, so you can put the TLE data, the amateurs.txt, the orbital parameters for the different amateur satellites on it. So it knows where the satellites are, it knows where you are, and it knows what time it is. With all of that, it's able to calculate the azimuth and elevation between you and the satellite, the relative velocity between you and the satellite, which it uses to calculate the Doppler shift, and automatically apply Doppler compensation to your transmit and receive frequency between you and the satellite. So, and then it also records the audio of a satellite pass, both uplink and downlink separately in separate channels. So the idea being that you tell it, you copy a current version of amateurs.txt onto it. You go outside, it gets a GPS sync, and it knows where the satellite is. When it comes up over the horizon, it opens up your squelch and it starts a recording. And then it tells you on the screen where to point your antenna. And it automatically adjusts the frequency for the Doppler compensation. And all you have to do is point your antenna and make contacts. And then it records the audio pass, so you can go back and do logging after the fact for you and stuff like that. So it was a great device.
That sounds so awesome.
Yeah, and I had all of that functionality working in the software, but the UHF radio module that I was using went unstable every time it tried to transmit into anything other than a 50 ohm resistive load. So when you put it into a bandpass filter, which is necessary to do full duplex,
Yeah.
it went into oscillations and caused all kinds of problems. This is the SA868 module by Nice RF. If you look at anyone selling like the DRA 818 or the SA 818 and they put a module around it, if you buy the VHF version, they're happy to give you a low pass filter. But if you buy the UHF version of it, they don't bother selling it with a filter, because as soon as you put the filter on it, the radio goes unstable. And so I need to find, I've been looking for a replacement module for it, and there isn't anything out there that does exactly what it does. So I started designing one myself, but that's going to take a fair bit of time to do. The other idea I have is to take the radios out of it entirely and turn it into just a serial port that controls a third-party radio, like a Kenwood or a something else. I'm kind of thinking that's going to be where I go with SOAR for the first revision that actually makes it out to market. But I wanted to get these out first.
Yeah, and SOAR looks really promising if you manage to fix these issues too, because it'll actually solve the problem. You'll need about 5 fewer hands to operate an FM satellite.
Exactly. That is exactly the problem I was trying to solve with SOAR. And to address Steve's question there, it's actually a smaller case, but the design is very similar. They're both Hammond cases. The OHIS stuff is in a 160 by 120 millimeter case. SOAR was in a 120 by 80, I think. 120 by 80. So it was smaller, but very similar design.
Yeah, and thank you. I see we're getting close to the hour mark here now, so this has really gone by fast. But thank you for being on. And if my viewers want to know more about your work and what you do, where can they find you?
So the Open Headset Standard is at ohis.org. My podcast is hamradioworkbench.com, also found where greater podcasts are distributed. My company website is electronics.halibut.com. And if you want to get on my mailing list to hear about product status updates and whatnot, everybody's saying, I want one now. Your best bet is to go to groups.io, because that's where I'm going to be announcing sales of products. And it's halibut-electronics.groups.io, I think is the URL for that. And then if you just want to connect with me socially, I am on Mastodon at smitty@halibut.com. And I also run the mastodon.hams.social instance. But my personal account is on a different instance because that's the way I roll. But if you want to get into Mastodon, go to mastodon.hams.social, create an account there, and then follow me as @smitty@halibut.com.
Yeah. Excellent. And I was going to ask you what's on your workbench, but I guess that's for another.
We'll be here
show,
for 3 more hours.
Yeah, exactly.
Yeah. You've listened to our podcast, haven't you?
Yeah, I have. I got a long commute to work, so it only takes me about 2 days to go through it. So
that's right.
But yeah, it's been really interesting to hear about that. And just to my viewers here, as you can see down there, I actually managed to point down. That's pretty good. I'm close to 1,000 subscribers now, so I'll be giving away a radio hopefully on my next live stream. And I'm also on Patreon at the moment, because running a YouTube channel is not by any means free. So just to take a little bit of a strain out of the family budget, if you want to support it, don't feel pressured to do it. But if you like my content and want to support it, feel free to take a look there. And that's about it. I got a couple of videos coming out next week, so be sure to try to see those. And I'll be back with another live stream next week, an hour earlier though, for those of you who are following me. It'll be Tim Golf 5 Tango Mike. He's going to be talking about antenna modeling. So that's what's coming up on my channel the next coming weeks. And on that note, 7-3 to all my viewers, and I hope to see you again.
73. Be good humans.